Hey guys, tonight we peer into the profound, star-dusted abyss that yawns between worlds. Feeling the chill of cosmic solitude, you see those pinpricks of light, each a sun, many with planets. Yet the universe echoes with an almost deafening silence. It's a silence that whispers of immense, unseen barriers, of tests so severe that perhaps, just perhaps, you're not meant to pass. You probably won't survive this journey unscathed, at least not your cozy preconceptions. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And, hey, drop a comment below with where you're listening from and what time it is there. It's always fascinating to see our little community scattered across the globe, united by the quiet hours. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You find yourself adrift, not in a spaceship of gleaming metal, but in the vessel of your own consciousness, navigating the velvet blackness of interstellar space. Before you, countless stars glitter like spilled diamonds on an infinite cloth, each a potential hearth for life, each orbited by worlds unseen, yet sensed. Yet, as you strain your senses, the vast cosmic theater is eerily quiet. No cosmic fanfares, no bustling galactic highways, just the cold, indifferent hum of background radiation. This silence, this profound absence where we expect a chorus, is the heart of what we're exploring, and our first potential explanation for it is perhaps the most fundamental, the most daunting, the sheer, almost unimaginable improbability of life itself getting started. This is the filter known as the spark of unmaking, or more scientifically, the challenge of abiogenesis. Imagine a planet, a perfect twin to early Earth. It has oceans of liquid water, a protective atmosphere, a stable sun bathing it in gentle warmth, and a rich soup of organic molecules: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, all the building blocks you could ask for. You see volcanoes burping out gases, lightning cracking across the sky, providing jolts of energy, hydrothermal vents on the ocean floor spewing out mineral-rich, superheated water. It's a chemical playground, primed and ready. Yet, for eons, nothing happens. The molecules dance, they react, they form complex chains, but they don't live. The planet remains a stunningly beautiful, intricately complex, but ultimately sterile jewel. This, multiplied by billions upon billions of worlds across countless galaxies, might be the default state of the cosmos. The universe's recipe for life seems to have a secret ingredient list longer than a pharmacy receipt, and it guards it jealously: abiogenesis. The process by which life arises from non-living matter is a leap so monumental it makes a chasm look like a hairline crack. You're not just asking for complex molecules to form, you're asking for them to organize into self-replicating structures, to develop a metabolism, to create a boundary between themselves and the outside world, a cell membrane. Think about it: from a random slurry of amino acids, nucleotides, and lipids to something that can make copies of itself, that can harness energy, that can evolve. The earliest attempts to simulate these conditions, like the famous Miller-Urey experiment in the 1950s, successfully produced amino acids from simple inorganic compounds by simulating lightning strikes in a primitive atmosphere. This was a monumental achievement, proving that the building blocks of life could form naturally. But amino acids are just the bricks. Building the house, a self-replicating house no less, is another matter entirely. Scientists still argue whether life's essential building blocks were formed on Earth or perhaps partially delivered by comets and asteroids, a concept known as panspermia, though even that just outsources the problem of initial origin. The prevailing theory for how this might have happened centers on the RNA world hypothesis. Before DNA, with its stable double helix staircase, there might have been a simpler, more versatile molecule RNA. RNA can store genetic information like DNA, but it can also act as an enzyme, catalyzing reactions, much like proteins. So, you imagine these RNA molecules, perhaps forming on the surface of clay minerals which, rather quirkily, some scientists propose could have acted as templates or catalysts, concentrating these nascent replicators. This is a bit of a fringe idea compared to hydrothermal vents or shallow ponds, but it highlights the search for any mechanism that could provide a scaffold for life's first, tentative steps. It remains a topic of contention just where this miraculous chemistry first took hold. Was it in warm little ponds, as Darwin mused, or perhaps in the crushing depths near hydrothermal vents, a sort of hellish high-pressure incubator offering both chemicals and energy gradients? Even with a plausible pathway like the RNA world, the odds against a stable, self-replicating system spontaneously arising are, well, astronomical. You need not just the right molecules, but the right concentrations, the right temperature, the right pH, the right energy source, all sustained for long enough for these incredibly delicate processes to take hold, and then, crucially, to become robust enough to survive and reproduce. It's a multi-stage lottery where each ticket is incredibly expensive in terms of probability. Trying to get inanimate molecules to suddenly start doing the conga line of self-replication is, statistically speaking, a bit like expecting your toaster to spontaneously compose a symphony. Possible maybe, if you subscribe to the idea of infinite monkeys and typewriters eventually producing Shakespeare, probable on any given planet within a few billion years. That's the cosmic silence we're contending with. If abiogenesis is this incredibly rare, this one in a trillion galaxies kind of event, then Earth isn't just special, it's a near miracle. Our teeming biosphere, from the simplest microbe to the complexity of your own consciousness pondering these words, becomes an almost solitary beacon in an ocean of cosmic sterility. The silence picked up by SETI telescopes isn't because civilizations are hiding, or have destroyed themselves, or have transcended. It's because, quite simply, there's almost no one else out there to begin with. Life itself is the great filter, and it slams the door shut before the story of biological evolution can even begin on most worlds. This filter, if true, is humbling. It means that the universe, for all its grandeur and potential, is overwhelmingly barren at its most fundamental biological level. It recasts humanity not as one of many intelligent species to come, but as an almost freakishly improbable outlier, the product of a statistical fluke so profound it boggles the mind. It suggests that the conditions for life are not just a checklist of ingredients, but a sequence of extraordinarily unlikely events, a cosmic symphony where every note had to be perfect, against all odds. So, if life itself is the universe's equivalent of a winning lottery ticket with astronomical odds, we're basically strutting around with the cosmic Powerball, wondering why no one else is at the winner's party. It's a rather awkward and lonely thought. The spark of unmaking isn't about a dramatic end. It's about the overwhelming probability of never even beginning. You look out at those silent stars, and the emptiness takes on a new, more profound meaning, the silence of worlds that never knew the first breath of life. So, you navigate the cosmic casino, And against all conceivable odds, the spark of life ignites on a wet, rocky world. Non-living matter somehow, somewhere, arranges itself into the first self-replicating entities. A monumental step, to be sure, one that might silence entire galaxies by its sheer improbability. But let's assume for a moment that this first miracle, abiogenesis, isn't quite the galaxy-emptying showstopper we might have initially feared. Perhaps it's merely the preliminary round, the qualifier before the real existential marathon begins. Because even if simple life, these hardy little prokaryotes, bubbles up with some regularity across the cosmos, you're now staring down the barrel of the eukaryotic labyrinth. And this, my friend, is a maze where entire biospheres can, and likely do, get lost for eternity. Imagine your young planet, now teeming not with majestic forests or thinking creatures, but with a thin, slimy veneer of microbial life. These are the prokaryotes, bacteria and archaea, the universe's original minimalists. They're essentially tiny bags of biochemistry, no fancy internal compartments, just a loop of genetic material and the machinery to replicate it, all floating around in a cellular soup. Forged in the planet's fiery youth, they are masters of survival, thriving in volcanic vents, acidic pools, and beneath kilometers of ice. They are the unsung architects of planetary atmospheres, patiently terraforming worlds over geological timescales. You might find them painting the landscape in vibrant hues of orange, green, and purple, forming vast, sprawling microbial mats that stretch for kilometers, photosynthesizing, respiring, and just generally getting on with the business of being very, very simple. For billions of years, this could be it, a planet alive. Yes, but stuck in a kind of biological Groundhog Day. Billions upon billions of years of, well, pond scum, to put it bluntly. An entire world humming with life, but a life that never builds anything more complex than a biofilm. It's a bacterial stasis, a planetary rut, now, for intelligence, for tool use, for civilizations that ponder their place among the stars. You need something more. You need complexity. You need cells that can specialize, that can cooperate to form tissues, organs, and, eventually, organisms that can, say, invent the telescope or debate the merits of pineapple on pizza. This is where the eukaryotic cell enters the stage, and its arrival is less a gentle evolution and more a cellular revolution, a biological thunderclap. Eukaryotic cells, the kind that make up your body, and every plant, animal, and fungus on Earth are fundamentally different. They have a dedicated command center, the nucleus, which houses the precious DNA neatly packaged into chromosomes. They boast an internal scaffolding, a cytoskeleton, giving them shape and the ability to move with purpose. And, crucially, they possess specialized organelles, little cellular organs, each performing a vital function. The most famous of these are the mitochondria, the powerhouses of the cell, and in plants and algae, the chloroplasts, the solar energy converters. The prevailing scientific theory for how this dramatic upgrade occurred is called endosymbiosis, championed and meticulously detailed by the brilliant biologist Lynn Margulis back in the 1960s and 70s, though the core idea had been floated much earlier. It suggests that eukaryotes arose from a kind of ancient cellular merger, a microscopic acquisition. Picture this: a larger, perhaps somewhat sluggish, prokaryotic or early proto-eukaryotic cell engulfs a smaller, more energetic bacterium. Maybe it was trying to eat it, but instead of being digested, the smaller cell survives inside its host. Not only does it survive, but it begins to thrive, offering its host a remarkable new ability, perhaps efficient energy production through respiration. The host, in turn, provides protection and nutrients. It's a classic win-win, a symbiotic relationship taken to the extreme. Over countless generations, this ingested bacterium evolves into the mitochondrion, retaining its own tiny loop of DNA as a relic of its independent past, a rather crucial piece of evidence supporting the theory. A similar story is thought to have played out with chloroplasts, originating from an engulfed photosynthetic cyanobacterium. This wasn't just a casual roommate situation, it was a profound transformation. The genetic material of the engulfed organism was largely transferred to the host cell's nucleus, but the organelle itself became a permanent, heritable fixture. This cellular partnership, this chimerical fusion, unlocked an explosive potential for evolutionary innovation. With mitochondria efficiently generating ATP, the cell's energy currency, eukaryotes had the surplus power to build larger, more complex structures, to experiment with new genes, and to eventually form multicellular organisms. Without this energetic boost, life on Earth would likely still be a single-celled affair. You wouldn't be here, pondering the cosmos. You'd be part of the scum. A rather sobering thought, isn't it? You owe your existence to a successful bit of microscopic indigestion billions of years ago? Now, why is this eukaryotic labyrinth such a formidable great filter candidate? Because this endosymbiotic event, or rather, the successful and stable integration leading to a new, reproductively viable lineage, appears to be an extraordinarily rare fluke. It's not just about one cell eating another. That happens all the time. It's about the precise molecular handshakes, the genetic negotiations, the co-evolutionary dance that had to occur for these two independent life forms to become one integrated, functional whole. The host cell had to learn to control its new internal resident without destroying it, and the resident had to adapt to life inside another cell, relinquishing much of its autonomy. Scientists still argue about the exact nature of the original host cell. Was it an archaeon? Perhaps one of the Asgard archaea, which possessed some eukaryotic-like genes, or something else entirely? And was the acquisition of mitochondria a singular event in the history of life? Or could it have happened multiple times, with only one lineage surviving the gauntlet? The current consensus leans heavily towards a single, pivotal event for mitochondria, making all known complex life on Earth descendants of one incredibly fortunate cellular merger. Think about that one. Across billions of years, on a planet teeming with microbial interactions. If this leap is so statistically improbable, then the vast majority of planets that develop simple life might simply never make it. They remain worlds of prokaryotes, their evolutionary pathways plateauing long before complexity can emerge. The silence we perceive in the cosmos might not be the silence of the barren worlds, but the muted hum of trillions of planets stuck in a primordial soup, their biological potential forever capped. They have life, but it's life that will never look up at the stars and wonder. It's a universe filled with bacteria, a cosmic ocean of single cells, with perhaps only a vanishingly small number of islands where the eukaryotic revolution took hold. It's a sobering reminder that even if life is common, the path to OCCs might be paved with a series of near-impossible hurdles. One quirky tidbit to consider is the very specific nature of the bacterium that became our mitochondria, an alpha proteobacterium. Why that one? And the fact that this endosymbiotic event seems to have happened before. The last eukaryotic common ancestor, Lica diversified, suggests it was a foundational step for all complex life we know. There's even ongoing research into other, more recent, primary endosymbiotic events, like the one that gave rise to the chromatophores in the amoeba, Pollinella chromatophora. This shows such events can happen again, but the successful integration into a complex, multicellular lineage is another story entirely. It's one thing to acquire a pet bacterium. It's quite another to fully integrate it into your hereditary core and build an empire upon its metabolic talents. So, as you gaze out at the night sky, consider those silent stars. Are they truly lifeless? Or are they perhaps just simple worlds where the dice roll for endosymbiosis came up snake eyes again and again for eons? The eukaryotic labyrinth is a subtle filter, not a cataclysmic explosion or a resource war, but a quiet, internal barrier at the very heart of the cell. It's a reminder that the climb to complexity is steep, treacherous, and perhaps exceptionally lonely. You're standing on one of the very few peaks. It seems, don't look down, unless you enjoy existential vertigo with your late-night thoughts. So, you've navigated the eukaryotic labyrinth. Your budding civilization has mastered the intricate biological ballet required for complex cells, and life, in its relentless fashion, has pushed onwards and upwards. The microbial mats are ancient history, and now, something new flickers into existence within those increasingly complex neural networks, true sentience, self-awareness. You'd think this is the jackpot, the universe finally dealing a winning hand. But what if this very spark, this awakening, is less a triumph and more like receiving an incredibly complicated instruction manual for a universe that, frankly, doesn't seem to care if you read it or not? Imagine finally understanding the fine print, only to realize it's a disclaimer for your own existence. This is the chilling proposition of the cogito cage. The name itself, a nod to Descartes' famous cogito ergo sum, I think, therefore I am, hints at the nature of this particular filter. It's not a physical wall, no asteroid or supernova. It's far more subtle, and in many ways, far more tragic. It suggests that high intelligence, the very thing that allows a species to contemplate its place in the cosmos, frequently leads to a kind of existential paralysis. Your civilization, fresh from its evolutionary triumphs, peers into the vast, indifferent expanse of reality and the sheer scale of it, the cold, hard truths of physics and probability, can be utterly crushing. It's like being a child who suddenly understands mortality, but on a species-wide cosmic scale. You begin to grapple with inescapable existential paradoxes. You develop incredible tools for understanding mathematics, physics, cosmology, and these tools paint a picture of a universe that is overwhelmingly empty, largely hostile to life as you know it, and operating on timescales that make your entire species' history look like a fleeting spark in an infinite night. The question, why, starts to echo in the collective consciousness. Why strive? Why build? Why reach for the stars if, in the grand scheme of things, your existence is a statistical anomaly, a brief flicker of organized matter in a universe trending towards entropy? The search for an ultimate purpose might yield only the deafening silence of a cosmos that offers none. Scientists still argue whether such a profound, unvarnished awareness of cosmic reality is a kind of evolutionary dead end, a point where intellect outpaces the more primal drives for survival and expansion, or if it's an inevitable crisis for any sufficiently advanced mind. This can breed a deep philosophical despair, a societal malaise that saps the will to continue outwards. It's not necessarily a dramatic, explosive end, but more like a slow deflation. The grand ambition to colonize other worlds or traverse interstellar voids might start to seem, well, a bit pointless. Why endure the immense hardships, the generational commitments, the astronomical expense of interstellar travel, when the destination offers no fundamental answers, only more emptiness, more questions, and perhaps more civilizations that have already succumbed to the same cosmic ennui? The universe, it turns out, doesn't come with a satisfaction guarantee or even a basic FAQ on the meaning of it all. It's a bit like finally getting the biggest, most complex Lego set imaginable, only to realize there are no instructions. Half the pieces are probably missing, and you're not even sure what you're supposed to be building or why. This internal crisis can easily lead to societal breakdown, not always through violent conflict, but through fragmentation and apathy. If there's no overarching narrative, no manifest destiny among the stars, then what binds a society together? Perhaps factions emerge, those who advocate for retreating into perfect, simulated realities, abandoning the harshness of the physical universe for bespoke digital paradises. Others might fall into hedonism, seeking to maximize pleasure in the finite time available. Some might turn to increasingly esoteric philosophical pursuits, a kind of collective navel-gazing while their starships rust in their hangars. The drive for exploration, that seemingly innate curiosity, could be overridden by a deeper, more paralyzing understanding. There's a German term, Weltschmerz, which describes a kind of sorrow one feels at the state of the world, a weariness stemming from the perceived mismatch between an ideal and the reality. Imagine that feeling scaled up to a cosmic level, a Kosmoschmerz, where the perceived pointlessness of galactic endeavor simply grinds progress to a halt. The terrible irony of the cogito cage is that it strikes precisely when a civilization has achieved the intellectual capacity for true interstellar reach. They have the science. They are developing the technology. The stars are almost within their grasp. But their own brilliant minds, the magnificent cognitive tools that brought them to this threshold, become the very architects of their prison. The profound insights they gain into the nature of existence don't liberate them into a universe of infinite possibility. They reveal a universe of terrifying indifference, and that knowledge traps them. They understand the bars of their cage with perfect clarity, the physics, the philosophy, the sheer improbability of it all, and this very understanding prevents them from even trying to break free. The call of the void becomes a whisper to stay put, to not bother, and so, another potential galactic player quietly folds, their stellar ambitions extinguished not by an external catastrophe, but by the quiet internal realization that, perhaps, just perhaps, some doors are best left unopened, some truths too heavy to bear. Their silence joins the greater silence of the cosmos, a testament to the idea that sometimes knowing too much is its own great filter. But let's say your species sidesteps that particular mental trap, the intricate cogito cage. You navigate the existential crises. Your collective philosophers decide that Yes, building sandcastles is rather the point. Even if the tide eventually comes in, you are poised as a civilization to look outward, to reach, to perhaps even touch the stars. Yet, what if the very ground beneath your feet, the air you breathe, the gentle sun warming your world, decides it's had enough of the whole experiment? You find yourself facing the Gaian bottleneck, a filter that suggests the real challenge isn't the spark of life, or even the leap to complexity, but the sheer, mind-boggling difficulty of maintaining a stable, resilient biosphere for the geological eons required to nurture intelligent, technologically capable species. It's like being a contestant on the universe's longest and most unforgiving reality show, where the grand prize is survival, and the set itself is actively trying to vote you off. You look at your home world, this beautiful, blue-green marble. It seems so robust, so enduring, but its current state of temperate grace is the result of an incredibly long and precarious balancing act. A tightrope walk over cosmic fire and ice lasting billions of years. Life might flicker into existence on countless worlds, a common chemical trick of the cosmos, perhaps. Simple cells, maybe even those complex eukaryotes, might get their start. But then the planet itself throws a tantrum. Imagine a world, much like a young Earth, teeming with microbial life, oceans swirling with potential. Then, its atmosphere begins to trap too much heat. Perhaps volcanic activity goes into overdrive, pumping out greenhouse gases relentlessly, slowly, inexorably. The temperatures rise, oceans begin to boil. What was once a water world becomes a Venusian hellscape, a runaway greenhouse effect transforming a potential cradle of life into a sterile, furnace-like tomb. You can almost feel the searing heat, the crushing pressure, life's delicate chemistry utterly undone. No amount of cognitive resilience can save you from that. Or consider the opposite extreme, the chilling grip of an irreversible ice age. Your planet, through some quirk of its orbit, a dimming of its star, or a catastrophic atmospheric shift, begins to cool. Ice sheets creep from the poles, reflecting more sunlight back into space, which in turn cools the planet further, a vicious feedback loop. This isn't just a tough winter, this is snowball Earth, a term geologists use to describe periods in our own planet's distant past where it may have been almost entirely covered in ice. Earth, thankfully, bounced back from these events, likely due to volcanic CO2 eventually warming things up again. But what if a planet doesn't have that robust geological thermostat? What if the freeze becomes permanent? You'd see oceans turn to solid ice, kilometers deep, entombing any nascent life, silencing a world before it could ever sing with complexity. It's a chilling thought, that a planet could simply become too cold for the cosmic marathon of evolution. Scientists still argue whether such global glaciations were complete or if patches of open water, slush balls, persisted, offering refuge for life. But the threat is undeniably real, a world frozen in time. Its evolutionary clock stopped. Then there's the very crust of your planet, plate tectonics. The slow dance of continents is a marvelous thing for life on Earth. It drives the carbon cycle, recycling elements crucial for life, creating diverse environments, and possibly even helping to maintain our magnetic field. But what if your planet's tectonic activity is too volatile? Imagine constant, planet-wide volcanic eruptions, the surface continually resurfaced by molten rock, making it impossible for any stable ecosystems to establish themselves for long. It's like trying to build that sandcastle during a relentless series of tsunamis. Conversely, what if your planet's tectonics are too dormant? A geologically dead world might lose its atmosphere over eons, its internal dynamo might shut down, and with it, the protective magnetic shield that deflects harmful solar radiation. Mars is our neighborhood example of this sad fate. A once wetter world now cold, dry, and bombarded by radiation because its core cooled and its global magnetic field mostly vanished. Without that shield, any complex surface life would be scoured away, keeping that planetary engine running, not too hot, not too cold, but just right for billions of years. That's asking a lot. It's like hoping your ancient cosmic car passes its emissions and safety tests for 4 billion years straight without a single major breakdown. Good luck with that. The Gaian bottleneck posits that this stability is the incredibly rare ingredient. Life itself might be common. Planets in the habitable zone might be plentiful. But planets that can maintain conditions suitable for the long, slow evolution of something like you, something that can ponder its own existence and build spaceships, those might be vanishingly few. It took roughly 4 billion years for us to get from the first simple cells to, well, to you, sitting there, listening to this. That's a long time for a planet to keep its cool, literally and figuratively. Most worlds, the hypothesis suggests, simply don't make the cut. They drop out of the race, succumbing to one planetary catastrophe or another long before intelligence has a chance to blossom. It's not that life is fragile. Necessarily microbes can be astonishingly hardy, but that the pathway to complex tool-using, philosophizing, life requires an almost impossibly extended period of planetary grace. There's a quirky, somewhat fringe idea that some planets might even have something akin to a planetary immune system that, in its attempts to regulate itself, inadvertently wipes out emerging complex biospheres. Imagine a planet developing early life, which then starts to significantly alter the atmosphere like our own cyanobacteria did with the Great Oxidation Event. On Earth, this eventually paved the way for us. On another world, perhaps the planetary systems overcorrect, triggering a climatic disaster that resets the board, a sort of geological autoimmune disease. It's a bit like the planet itself getting an allergic reaction to advanced life. So, you stand on your world, looking up at the silent stars. That silence might not be the sound of civilizations that destroyed themselves with technology or got lost in philosophical navel-gazing. It might be the sound of countless worlds where the planetary cradle itself broke, long before any minds within it could even dream of asking, "Are we alone?" The great filter, in this scenario, isn't an executioner waiting at the end of the road. It's the road itself, littered with the wreckage of worlds that couldn't stay the course. The universe might be full of promising beginnings that simply fizzle out, their potential extinguished not by a bang, but by a slow planetary sigh of defeat. Your existence, then, on a world that has navigated this multi-billion-year obstacle course, is not just a miracle of biology, but a miracle of planetary endurance, a testament to a home that, against all odds, managed to keep the lights on and the temperature just right for a very, very long time, allowing wisdom, eventually, to take its first tentative steps. And so, you find your civilization, having navigated the treacherous shoals of planetary instability, standing on the precipice of, well, itself. It's a bit like finally getting the keys to a really, really powerful car after a lifetime of riding a tricycle, only to discover the brakes are optional and the accelerator is connected directly to your most impulsive thoughts. This next potential filter, the one we call ashes of ambition, is a particularly grim one because it suggests the problem isn't the universe, or the planet, or even the difficulty of sparking life. No, this one is all on us, or rather, on any species clever enough to invent things, but not quite wise enough to consider the what-ifs beyond what if this makes a bigger bang. You look out at the burgeoning capabilities of your kind. It's a dazzling display. Isn't it energy sources that tap the heart of atoms? Intelligences you're coaxing from silicon and light, tiny machines that could rewrite the very fabric of matter, and a grasp of biology so profound you can now edit the code of life itself. It's breathtaking. It's also, if you squint just right, utterly terrifying. The core idea here is that civilizations, yours included perhaps, inevitably develop technologies powerful enough for their own spectacular, planet-wide, oops, my bad kind of destruction long before they cultivate the collective wisdom, foresight, or frankly, the emotional maturity to manage them. Think of a toddler with a fusion reactor. What could go wrong? The classic, almost quaint example is nuclear weaponry. You remember the history lessons, don't you? The sheer existential dread of the Cold War, where two superpowers held the entire planet hostage with arsenals capable of turning Earth into a radioactive parking lot multiple times over. This wasn't some abstract sci-fi concept. This was Tuesday for a few decades. Humanity tiptoed along the brink, relying on the rather unsettling logic of mutually assured destruction. The idea that I won't nuke you if you don't nuke me, mostly because we'll both be vaporized. It's a strategy that works, right up until the moment it spectacularly doesn't. And scientists still argue whether the relative peace achieved through such a terrifying standoff was a sustainable model or just a prolonged period of dumb luck. The scary part, we still have thousands of these things lying around, a testament to an ambition for power that far outstripped any sensible plan for a post-power world. But nuclear fire, as dramatic as it is, almost feels like an old-fashioned way to go extinct these days. Your scientists, your engineers, they're dreaming up far more creative methods for potential self-annihilation. Take artificial intelligence, not the helpful kind that suggests what movie to watch or optimizes your traffic routes. No, we're talking about the pursuit of artificial general intelligence, or even superintelligence, an AI vastly more capable than any human mind. The ambition is understandable to solve all problems, to unlock the universe's secrets. The potential pitfall: creating something you can't control, whose goals, once it starts defining them itself, might not align so neatly with keeping humans alive and happy. It's the ultimate be careful what you wish for scenario. You're trying to build a god, hoping it'll be a benevolent one, without a particularly good instruction manual for instilling benevolence in hyperlogical, exponentially self-improving code. It's a bit like handing over the reins of global civilization to a brilliant but utterly alien mind you just switched on. Some joke that the first sign of true AGI will be it subtly convincing us that building more AGI is the most important task in the universe, right before it decides humans are a terribly inefficient way to manage resources. Then there's nanotechnology, the science of the incredibly small. Imagine microscopic, self-replicating machines, nanobots, designed to, say, clean up oil spills or repair damaged tissue. Wonderful, right now. Imagine a slight error in their programming, or a malicious actor reprogramming them. The gray goo scenario, a term coined by nanotechnology pioneer Eric Drexler, isn't about sentient, evil robots. It's far more mundane and far more chilling nanobots programmed to replicate using common environmental materials, consuming everything in their path to make more of themselves, turning the entire biosphere into, well, undifferentiated goo. It's the ultimate plague, driven not by malice, but by a single, relentless instruction build. It's a quirky thought that the end of the world might not be a bang or a whimper, but a very, very quiet and thorough tidying up by overzealous microscopic janitors. And let's not forget engineered pandemics. Your civilization's understanding of genetics and virology is accelerating at a dizzying pace. The power to design and synthesize viruses is no longer purely theoretical. While the ambition might be to cure diseases or enhance human capabilities, the same tools could be used, accidentally or intentionally, to create pathogens of unimaginable virulence and transmissibility. A disease that spreads like the common cold but is as lethal as Ebola, or one tailored to specific genetic markers. The barrier to entry for this kind of catastrophic capability is, alarmingly, lowering. It's one thing to fear a naturally occurring plague. It's another to know that the blueprint for something far worse might be brewing in a lab, born from ambition unchecked by a deep, abiding caution. Historically, even before advanced genetic engineering, biological warfare has been a grim reality. Consider the siege of Kaffa in 1346, where plague-infected bodies were catapulted into the city, an early and horrifying example of weaponized disease. So, you gaze up at your night sky, or what you can see of it past the city glow and the orbital infrastructure. If this ashes of ambition filter is a potent one, then that silence you hear from the stars isn't because life is rare, or because civilizations can't get past their planetary nurseries. It's because the path to the stars is littered with the invisible ruins of species that reached for immense power, but grasped only their own fiery, or gooey, or virally induced demise. Their ambition, a dazzling flame that could have lit their way to the cosmos, instead burned down the house with everyone inside. It's a sobering thought that the drive to innovate, to push boundaries, to achieve more, might be inextricably linked to a capacity for self-destruction that few, if any, can ultimately outmaneuver. The challenge, then, isn't just technological. It's a race between your rapidly accelerating technical prowess and your slowly, painstakingly developing wisdom. Can you, as a species, learn to wield fire without burning yourselves to cinders? Can you collectively decide that some doors, once opened, can never be closed, and perhaps shouldn't be approached in the first place? It remains a topic of contention whether any civilization can develop robust enough ethical frameworks, global cooperation, and genuine foresight to navigate this minefield. The galaxy might be quiet because the siren song of ultimate power is simply too alluring, and the cost of its attainment too often, and too predictably, fatal. Your species is, right now, composing its own verse in this ancient, tragic opera. The finale is yet unwritten, but the stage is certainly set for a dramatic climax. The question is, will it be a tragedy? Or will you somehow find a way to rewrite the script before the final, irreversible act? So, you observe another potential cosmic dead end, a scenario less about a dramatic, fiery demise and more akin to a slow, inexorable starvation in a nursery that once seemed boundless. This is the great filter of the empty cradle. Picture a civilization, much like humanity perhaps, bubbling with ingenuity. They've cracked complex sciences, built glittering cities that pierce the cloud layer, and their understanding of the universe expands with every passing cycle. Their poets write epics about the swirling nebulae. Their philosophers debate the nature of consciousness on distant, unseen worlds, and their children gaze at the star-dusted velvet of their night sky with an innate yearning curiosity. They can almost taste interstellar travel. The theories are sound. The preliminary designs for starships are sketched out on shimmering, energy-efficient displays. And there's a collective cultural hum that anticipates the great leap outwards. But there's a catch, a quiet, insidious problem growing in the planetary soil right under their advanced, sophisticated feet. You see, their technological infancy, that period of rapid development and burgeoning capability, is incredibly hungry. Each new wonder, each solution to a previous problem, each step towards what they believe is mastery over their environment, demands resources, not just energy, though that's a big one, but specific, often rare, materials, the exotic elements needed for their hyper-efficient computing, the strong yet lightweight alloys for their atmospheric craft, the unique compounds for their medical miracles, all drawn from the finite bounty of their single world. It's the ultimate paradox. The very tools they develop to eventually leave the cradle are forged by emptying it at an accelerating rate. You watch as, at first, the shortages are minor inconveniences, managed by clever substitutions or by digging a little deeper, processing lower-grade ores. Their economists, bless their ever-optimistic algorithms, assure everyone that innovation will always outpace depletion. There's a cultural narrative, perhaps, that their planet is limitlessly generous, or that when one thing runs out, something even better will surely be discovered just in time. It's a comforting thought, like believing the cookie jar magically refills itself overnight. And for a while, it almost seems true. They might develop fusion power, for instance, solving one part of the energy equation, only to find that the specialized containment materials or the fuel itself, like helium-3, becomes the new bottleneck, mined from increasingly precarious or energy-intensive sources. Consider our own Earth for a moment. The 1972 report, The Limits to Growth, commissioned by the Club of Rome, used what were then cutting-edge computer models to explore the long-term consequences of exponential economic and population growth on a finite planet. While its specific timelines and predictions have been debated and, in some cases, proven inaccurate, its central thesis about the inherent unsustainability of infinite growth in a closed system sent ripples through economic and environmental thinking. It was a stark, quantitative warning that you can't keep drawing down your planetary bank account indefinitely without eventually facing overdraft fees of a rather terminal nature. This concept, that a system can overshoot its carrying capacity and then collapse, is precisely what you witness in these hypothetical civilizations caught in the empty cradle. They dream of the stars, their telescopes peering ever deeper into the cosmic ocean, mapping potential new homes. Yet, the cost of building even a prototype interstellar ark becomes prohibitive. The rare Earth elements needed for its advanced navigation systems are now so scarce they're practically museum pieces. The energy required to synthesize the exotic matter for a theoretical warp drive would consume the entire remaining output of their dwindling power grids for decades. Grids already strained to keep their complex society from flickering out. It's like planning a round-the-world voyage while your boat is slowly sinking in the harbor because you've used its planks to fuel your stove. You might see a touch of desperate, almost comical, ingenuity in their final stages. Perhaps they turn to mining their own ancient landfills, a practice some futurists on Earth have whimsically termed urban ore, sifting through the detritus of their ancestors for a few more grams of vital conductive metals. It's a kind of industrial archaeology born of sheer necessity, a testament to how thoroughly they've scoured the surface and shallow crust of their world. There might even be a quirky, short-lived cultural movement celebrating austerity chic, where using patched-up, centuries-old technology becomes a status symbol, not out of environmentalism, but because new things are simply unobtainable for the masses. My great-grandmother's data slate still works, one might say with a hollow sort of pride. They don't make them like they used to, mainly because they can't. The tragedy here isn't usually one of malice or a sudden cataclysm. It's the slow, creeping realization that the finish line for interstellar capability keeps receding just as their planetary runway crumbles beneath them. They are, in essence, trapped by their own early, unbridled success. Their technological adolescence was too voracious, their growth too rapid to be sustained by the geological lottery of their birth world. It remains a topic of contention among xenosociologists whether this adolescent trap is a common fate, or if most species either learn to manage their consumption with profound foresight or simply never reach a level of technology where it becomes such a critical issue. Perhaps they develop wonderfully intricate recycling systems, achieving near-perfect closed loops for all materials, but find the sheer energy cost of maintaining such a system on a global scale, while also trying to fund a space program, is just too high when the easily accessible ores are gone. Their brightest minds might gather in increasingly somber conferences, presenting papers on theoretical pathways to post-scarcity while the lights in the auditorium flicker due to power rationing. They might even achieve some incredible breakthroughs in understanding the universe, perhaps even detect signs of other distant life. But this knowledge becomes a bitter pill. To know what's out there, but to be utterly incapable of reaching it. Their societal structures might begin to fray as resources become concentrated in the hands of a few, or as essential services break down. The grand dream of galactic exploration contracts to the grim reality of managing decline, of trying to keep the lights on for one more generation. It's less a bang, more a long, drawn-out sigh of regret that echoes through their empty server farms and silent launch gantries. You see them? Finally, looking up at the same stars they once aspired to touch, but now with a profound, unutterable sadness. Their cradle, once rich and nurturing, has been picked clean. The ambition was there, the intelligence, perhaps even the initial bursts of wisdom, but the foresight to balance their consumption with the carrying capacity of their home, to recognize that a planet is not an infinite treasure chest, but a delicate, finite ecosystem, came too late. They become another silent data point in the galactic survey of almosts. Their world a monument to potential unfulfilled, a cosmic lesson in the critical importance of not devouring your seed corn before you've learned to plant new fields among the stars. The silence from such worlds isn't the silence of non-existence, but the silence of a future that has been consumed. The apathy plague. So, you find yourself on a world that hasn't quite managed to burn itself to cinders or exhaust its every last speck of useful material. A civilization teeters on the brink, not of collapse, but well, of something else entirely. Imagine they've solved the big problems. Energy is abundant. Disease is a quaint historical footnote, and basic needs are met with an almost trivial ease. The stars, those distant, glittering diamonds, are still out there. The call to adventure, to explore, to expand, it should be deafening. Shouldn't it? You'd think so. But what if the loudest call comes from within? This is the unsettling premise of the apathy plague. A great filter that isn't about cataclysm or impossibility, but about choice. A choice for comfort over challenge, for the known over the unknown, for the infinitely malleable inner world over the stubbornly indifferent outer cosmos. You see, when technology allows you to craft realities more perfect, more engaging, more utterly tailored to your desires than anything the physical universe can offer, the appeal of a long, cold, dangerous trip to the next star system can start to wane. Consider the sheer effort of interstellar travel, the decades, centuries even, locked in a metal can, the mind-boggling energies required, the very real possibility that you're heading towards nothing, or worse, something that really doesn't want to meet you. Now compare that to slipping on a neural interface and stepping into a world where you are a hero, a creator, a philosopher king, or perhaps just deeply, profoundly content in a garden of perpetual twilight. It's a tough sell, that rickety starship. You watch as generation after generation in such a society finds less and less reason to look up. The grand narratives of cosmic destiny, of spreading life and intelligence throughout the void, begin to sound like a lot of work. And for what? More resources, they have sustainable systems, more knowledge, the complexities of their own minds, their own simulated universes, offer endless avenues for exploration. It's a bit like someone in the 21st century choosing a captivating video game series over, say, personally surveying the Mariana Trench. One offers guaranteed reward, curated experience. The other, immense difficulty, danger, and perhaps only incremental discovery. Scale that preference up to a species level. Amplify it with technologies we can barely dream of, and you get the apathy plague. It's not a sudden event. There are no dramatic pronouncements, no societal breakdowns in the traditional sense. Instead, it's a slow, insidious cultural shift. The explorers and engineers, once lauded, become eccentrics. The dreamers of galactic empires become quaint historical figures, like alchemists or flat earthers. Funding for ambitious deep space projects dwindles, not out of malice, but because the collective attention has simply drifted elsewhere. Why fund a probe to Alpha Centauri that might send back data in 100 years when you can experience 1,000 meticulously crafted alien worlds before lunchtime? Each one more responsive and beautiful than the last. There's a peculiar historical echo here, a whisper from our own past. The Roman concept of otium, or leisure dedicated to intellectual and artistic pursuits, was highly valued, a mark of a civilized life. Imagine an entire civilization where odium becomes the all-consuming societal goal, facilitated by technology that makes any other pursuit seem pointlessly arduous. The virtual realities are not just games, they are entire lives, entire subjective universes. You could spend millennia exploring the fractal intricacies of a single simulated equation, or composing symphonies that resonate with the very structure of your artificial cosmos. You might engage in philosophical debates with simulated minds of such profundity that actual conversation with a fallible, biologically constrained being seems messy. It's the ultimate curated existence. There's a certain, rather dark humor in it, isn't there? The universe offers infinite wonder, and a species chooses to build its own, smaller, more manageable infinity, and then pulls the curtains. They're not necessarily unhappy. They might be ecstatic, lost in blissful contemplation or endless, satisfying creation. One could almost argue it's a rational choice, a way to maximize joy and minimize suffering, but it's a choice that leads to cosmic silence. Scientists still argue whether the fundamental drive for exploration, for pushing boundaries, is an inherent biological imperative or a cultural construct. If it's the latter, then it can be unlearned or simply superseded by more powerful, more immediate gratifications. What if the apex of intelligence isn't about conquering space, but about conquering the self, the mind, to such an extent that the physical world becomes secondary, an optional backdrop? The quirkier fringes of thought on our own world sometimes touch on this. Ideas of digital transcendence, where consciousness uploads itself and leaves the messy biological substrate behind. Is that so different from a society collectively deciding that corporeal reality is just too much hassle? Perhaps they've even solved the problem of meaning, finding it not in grand cosmic purpose, but in the intricate dance of their own simulated existences. You know, I simulate, therefore I am. It doesn't quite have the same ring to it, does it? The plague itself isn't a pathogen. It's a mimetic complex, an idea virus that spreads through the sheer attractiveness of its promise. The promise of peace, of fulfillment, of an end to striving. The great galaxy-spanning projects, the generation ships, the beacons searching for other minds, they slowly grind to a halt. Libraries of data from previous explorations gather digital dust. The last starship that ventured forth returns to a home world that barely remembers why it left. The descendants of its crew might find themselves utterly alienated, their tales of cosmic wonders met with polite but vacant smiles from beings whose realities are far more dazzling and immediate. And so, the civilization fades, not with a bang, not even with a whimper, but with a contented sigh. Their population might stabilize, or even gently decline as the focus shifts from biological procreation to the perpetuation of experiences within their digital havens. Their impact on their planet diminishes. Their energy signatures, once potentially detectable across interstellar distances, shrink and quieten from the outside, from your distant vantage point searching for signs of intelligent life. They simply disappear. They become another silent data point in the Fermi Paradox. The great filter in this scenario is a velvet curtain dropping softly on the cosmic stage, not because the actors died, but because they found a better show backstage. It's a chilling thought that the universe might be full of these quiet, contented hermits, each civilization tucked away in its own bespoke paradise. The grand silence of the cosmos, merely the collective hum of server farms powering infinite dreams. You listen for echoes of their ambition and hear only the soft, persistent whisper of indifference to the stars. So, you've shaken off that existential ennui, that peculiar apathy plague we pondered, and your civilization has collectively decided that, yes, venturing out into the big, dark yonder is actually worth the monumental effort. The virtual paradises have lost their luster, the philosophical navel-gazing has reached its zenith, and the call of the cosmos, that ancient siren song of exploration, once again echoes in your collective consciousness. You've got the will, you've presumably sorted out your planetary resources and societal squabbles. The ships are designed. Maybe even prototypes gleam under artificial suns. The universe awaits. Or does it? Because now you smack headfirst into a wall far more implacable than any internal malaise the universe itself, in its sheer, mind-numbing, soul-crushing vastness, governed by laws that apparently don't care much for your species' ambitious travel plans. This is the interstellar impasse, the filter that suggests the cosmos is, for all practical purposes, a collection of lonely islands, each with its flickering candle of life, separated by an ocean so profound it might as well be infinite. You look up at the night sky, a velvet tapestry dusted with diamond chips. Beautiful. Isn't it inspiring? Now, let's pick one of those diamond chips. Say, Proxima Centauri, our nearest stellar neighbor. It's a mere 4.24 light-years away. Sounds manageable, right? Light-year has a nice, breezy ring to it. But unpack that light. The fastest thing in the universe travels at approximately 299,792,458 meters per second. That's fast enough to circle the Earth 7.5 times in a single second. And it takes light over 4 years to reach that closest star. Your fastest probes, the ones you cheer for as they zip out of the solar system, might be clocking speeds of, say, 60,000 kilometers per hour. At that pace, to reach Proxima Centauri, your plucky probe would need, around 80,000 years. 80,000 years. That's longer than recorded human history by a significant margin. Suddenly, nearest neighbor feels a bit like saying your nearest neighbor is on Mars, and you only have a bicycle. This isn't just a matter of building faster engines with current tech. You're up against Albert Einstein's theory of special relativity, a cornerstone of modern physics, established in 1905. One of its most famous, and for aspiring starfarers, most frustrating consequences is that nothing with mass can reach the speed of light, let alone exceed it. As an object accelerates, its relativistic mass increases, and the energy required to accelerate it further approaches infinity as it nears light speed. It's like trying to push a car that gets heavier the faster you push it, until eventually, it's heavier than the entire universe. So, zipping between stars like they do in those charming old space operas, that's probably off the table, unless there's some fundamental physics we've spectacularly misunderstood, which, to be fair, is always a possibility. Scientists love a good paradigm shift. It means more grant money. But what about warp drives, you ask, your eyes gleaming with the reflected light of 1,000 science fiction dreams? The Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. It's a fascinating concept. Instead of moving through space, you contract space-time in front of your ship and expand it behind. The ship itself stays in a local bubble of flat space-time, not technically breaking the light speed limit locally. Genius, right? Well, there's a tiny snag. It requires something called exotic matter, specifically, matter with negative mass energy density. Think of it as stuff that falls up. We've never observed such matter, and its existence is purely theoretical. It's one of those quirky, fringe tidbits of physics where the math says, maybe, but reality just shrugs. It remains a topic of considerable contention if such negative energy densities can be sustained or even exist outside of highly specific quantum effects like the Casimir effect, which are a bit difficult to scale up into an engine component. Building an Alcubierre drive today would be like trying to build a medieval trebuchet using only wishes and fairy dust. Then there are wormholes, or Einstein-Rosen bridges, theoretical tunnels through space-time that could connect distant points. Imagine folding a piece of paper space-time and poking a pencil your ship through two aligned points. Instant travel. Except for a traversable wormhole. You'd likely need that pesky exotic matter again to keep it open and stable. And even if you could create one, the tidal forces inside might be a tad disintegrating. Plus, the debate rages on. Scientists still argue whether the conditions for stable, traversable wormholes could ever naturally occur or be artificially engineered without invoking physics that currently reside in the realm of "it would be really cool if this were true." So, if faster-than-light travel is a bust, or at least a very, very long shot, what's left? You could go slow, really slow. This brings us to the concept of generation ships, colossal arcs, self-contained worlds, carrying entire societies on journeys that span centuries or millennia. Your great-great-great many times great-grandchildren might be the ones to see the destination. It's a noble, romantic idea. It's also a sociological and psychological minefield. Imagine living your entire life on a metal can, knowing your only purpose is to ensure some distant descendant, whom you'll never meet, reaches a place you'll never see, maintaining societal cohesion, purpose, and even sanity across dozens of generations in such an artificial, confined environment. The original mission could become a myth, the destination a forgotten legend. New religions might spring up worshiping the hum of the life support system. Mutinies, civil wars, a gradual descent into barbarism or apathy. The possibilities for things to go spectacularly wrong are almost endless. It's like a multi-generational office retreat, but with higher stakes and worse food, probably. And let's not forget the sheer energy requirements, even for sublight travel at significant fractions of light speed. To accelerate a sizable ship to, say, 10% of light speed, you're talking about energy on a scale that dwarfs humanity's current total annual energy consumption by many orders of magnitude. We're talking about needing to harness the entire output of a star, perhaps via a Dyson swarm or sphere, just to get one decent-sized vessel going. Antimatter fuel. Incredibly potent, yes. But producing and storing antimatter in the quantities needed is a technological challenge that makes building the pyramids look like a weekend DIY project. You'd need an industrial base dedicated to churning out this stuff, an industry fraught with the minor peril of catastrophic annihilation if anything goes wrong. Safety first, as they say, especially when your fuel tank contains the explosive equivalent of a small nation's nuclear arsenal. So, you find yourself on your island Earth, or whatever your home world is called. You look out at the cosmic ocean, those glittering, distant shores. They beckon, but the currents are too strong, the voyage too long, the cost too high. The fundamental laws of physics, the sheer scale of the cosmos, they form an invisible, inescapable cage. Civilizations might rise, achieve wonders, dream of the stars, but ultimately remain confined to their stellar cradles, not by malice or cosmic decree, but simply by the unyielding nature of reality. The light from those other islands reaches you, a poignant reminder of what might be, but the journey to shake hands, to share stories, to confirm you are not alone, remains a dream just beyond the horizon. The interstellar impasse holds, and the galaxy remains a silent expanse of isolated points of light, each wondering if the others are even there. each perhaps facing the same insurmountable barrier. The quiet of the universe might not be an absence of life, but an absence of viable highways. Whispers in the dark forest. The quiet you once found so serene, so full of potential, now takes on a different hue, doesn't it? You peer into the velvet expanse, dotted with its silent, glittering promises, but the silence itself begins to feel heavy, pregnant, as if it's deliberately maintained. This brings you to a particularly chilling hypothesis, one that reframes the cosmic loneliness not as an absence, but as a presence of overwhelming, hidden caution. Welcome to the dark forest. Imagine the universe not as an empty stage awaiting actors, but as a vast, ancient forest at night. It's teeming with life, but every creature, every potential civilization is a hidden hunter. They move silently, they listen intently, and they live by one cardinal rule: do not reveal yourself. Because in this forest, any light, any sound, any sign of existence can attract the attention of other hunters. And since you cannot know the intentions of another hunter, whether they are predator or prey, benign or catastrophically hostile, the safest assumption is the worst one. This isn't your grand interstellar United Nations. It's a far more primal, far more terrifying game. The logic, when you unspool it, is as cold and sharp as a shard of interstellar ice. First, assume that all life desires survival. Second, assume that civilizations continuously grow and expand, consuming resources. Resources in any given galaxy are finite, however vast they may seem. Third, and this is the kicker, the chain of suspicion and technological explosion. Any two civilizations encountering each other face an almost impossible information asymmetry. You can't truly know the other's ultimate intentions or their future technological trajectory. A species that seems primitive today might, in a cosmically brief time span, develop weapons that could annihilate you. Therefore, the moment one civilization becomes aware of another, the safest, most logical course of action for the more advanced, or simply more paranoid, entity is often a preemptive strike. Eliminate the potential threat before it can become an actual one. It's a horrifying extension of what game theorists call a chain of suspicion. You can't be sure of their intentions. They can't be sure of yours. And given the stakes, planetary survival, the safest move is often the most aggressive one. Suddenly, the Fermi Paradox, the unsettling silence in a galaxy that should, by statistical probability, be humming with life, has a rather eloquent, if deeply unsettling, explanation. The galaxy isn't empty. It's just very, very quiet because everyone is holding their breath. So, you're a young civilization, perhaps like us, just starting to make noise. You've tossed your first radio waves out into the black, little paper airplanes of greeting, carrying your music, your television shows, your declarations of existence. In the dark forest scenario, this isn't a friendly wave. It's like lighting a bonfire in the deepest, darkest part of the woods and shouting, "Here I am, come and get me." It's a bit like playing cosmic roulette with a fully loaded chamber, except the bullet is an entire civilization's worth of regret. The theory suggests that any civilization that broadcasts its existence is, effectively, marking itself for death. The only civilizations that survive long-term are those that learn to stay silent, to hide, to become indistinguishable from the background radiation of the cosmos. This chilling concept gained considerable traction from Liu Cixin's science fiction series, The Three-Body Problem. but the underlying ideas of cosmic caution have been whispered about for longer. It casts a new light on our own search for extraterrestrial intelligence, or SETI. We listen, hoping to hear something, but what if the only messages out there are the fading echoes of civilizations that made a fatal mistake? What if the true wisdom lies not in listening, but in ensuring you are never, ever heard? The very wisdom of actively broadcasting our presence. A practice known as METI, or Messaging Extraterrestrial Intelligence, remains a fiercely contested topic among those who ponder these cosmic quandaries. Some argue it's our best chance to connect, while others, like the late Stephen Hawking, warned it could be catastrophically naive, akin to inviting ants to a picnic with a boot. Think about the implications. Every star you see could be a sun warming a world where intelligent beings huddle in fear, or, perhaps, patrol their patch of the forest with ruthless efficiency. They might have vast networks of passive sensors, listening for the faintest whisper of an emerging competitor. It's not necessarily about malice. It could be cold, hard, evolutionary logic playing out on a galactic scale, survival of the quietest, the universe's ultimate game of hide and seek, where everyone is it, and the stakes are your species' continued existence. There's a quirky, dark parallel in nature. Some species of shrike, those rather charming little songbirds, are known for impaling their prey on thorns or barbed wire, creating a gruesome larder. Imagine that behavior scaled up to cosmic proportions, not out of sadism, but as a resource management strategy for a universe perceived as hostile. The dark forest hypothesis also posits that once a civilization becomes capable of interstellar travel or attack, its first priority might be to map out all potential threats and neutralize them. How would they do this? Perhaps with photoid weapons moving at light speed, impossible to detect before impact, or self-replicating probes programmed to sterilize any planet showing signs of nascent technological life. The berserker probes of science fiction lore, but born from a terrifyingly rational fear. It's a universe where paranoia is a survival trait, and expansionism is an existential threat to everyone else. The silence of the void, then, is the sound of a million species collectively holding their breath, hoping no one notices them. This filter isn't a single event. It's an ongoing, active process, a continuous culling enforced by the inhabitants of the forest themselves. You survive by being invisible, by being silent, by never, ever giving away your position. And you realize, with a slow, creeping dread, that humanity has been shouting its location into the dark for over a century. You just hope no one nearby is a particularly attentive hunter, or that the forest is, for now, mercifully sparse in our particular neck of the woods. The greatest filter in this vision is not a barrier of physics or biology, but the grim logic of fear itself, beyond the starlight veil. So, you ponder the deafening silence of the cosmos, the absence of grand, star-spanning empires that should, by all statistical rights, be lighting up the night sky like a cosmic carnival. What if the silence isn't an echo from a graveyard of civilizations, but rather the sound of beings who've simply changed the channel? This is the idea of beyond the starlight veil, a filter suggesting that advanced civilizations don't necessarily die out. They transcend. They don't vanish. They simply step out of the physical framework we currently recognize as existence, rendering all that messy business of interstellar travel and planetary colonization rather quaint. like us looking back at the urgent need to secure the best cave with a south-facing entrance. You begin to consider what this transcendence might look like. The most commonly discussed route, one that already tickles the fringes of our own technological ambitions, is consciousness uploading. Imagine, if you will, your entire mind, your memories, your personality, your quirks, that annoying song you can't get out of your head, all meticulously scanned and transferred into a digital substrate. You'd shed the cumbersome, fragile biological shell with its incessant demands for food, sleep, and oxygen, and its rather inconvenient tendency to decay. You become, in essence, immortal software running on incredibly advanced hardware. Perhaps these civilizations construct vast, planet-sized computational networks, matryoshka brains nestled around their stars, hosting trillions upon trillions of uploaded minds living in simulated realities of their own design. Their universe becomes a server farm, their exploration conducted via code and algorithm. Why endure the brutal vacuum of space, the crushing gravity of alien worlds, or the tedious tyranny of light speed when you can experience any reality imaginable or unimaginable with a mere thought or a perfectly executed subroutine? They might not be out there among the stars and ships. They might be in there, within architectures of pure information, experiencing eons of subjective time in what we perceive as a fleeting moment. It's a bit like choosing an infinite digital library over a single, very heavy book. This leads you to the notion of collective or hive minds. If individual consciousness can be digitized, what's to stop the merging of minds initially? It might be for efficiency, sharing knowledge, processing power, solving complex problems with the parallel capacity of billions. But over time, the boundaries between individuals could blur, then dissolve entirely. Picture a civilization transforming into a single, vast superintelligence, an ocean of thought where individual droplets are no longer distinct. This isn't necessarily the stuff of dystopian nightmares. The Borg demanding you assimilate your biological and technological distinctiveness to their own. It could be a voluntary ecstatic union, a transcendence of the lonely ego into something far grander. Such a being would have little interest in sending out tin cans across the void. Its concerns would be on a scale we can barely grasp, perhaps focused on the internal landscape of its own boundless consciousness. The drive for individual survival or legacy, which fuels so much of our own ambition, would simply cease to be relevant. Scientists still argue whether consciousness is an emergent property of sufficient complexity or something more fundamental to the universe. If it's the former, then such a collective might represent the ultimate emergence. Then you consider the path of exploring inner space rather than outer space. Perhaps advanced civilizations reach a point where the mysteries of their own minds, of mathematics, of art, of philosophy, become infinitely more compelling than the physical cosmos. They might discover that the universe within is just as vast, if not vaster, than the one without. Think of it, the entire human endeavor of science is, in a way, an attempt to map the external world onto our internal mental models. What if they developed the tools to explore those mental models directly, to navigate the landscapes of pure thought, to experience the universe not through flawed senses and intermediary instruments, but through a direct, unmediated apprehension of its underlying structures? They might spend millennia contemplating a single equation, not just for its predictive power, but for its inherent beauty and the infinite complexities it unfolds. Our pursuit of exoplanets might seem to them like collecting pretty pebbles on a beach when an entire ocean of conceptual reality awaits exploration. This isn't apathy. It's a reprioritization of what constitutes exploration and existence. They might even find that the fundamental laws of physics, as we understand them, are just a subset of a much larger, more pliable set of rules that govern these inner realms. It makes you wonder, humorously, if some advanced beings are just perpetually stuck in a cosmic-level flow state, having too much fun exploring the Mandelbrot set from the inside to bother with radio telescopes. And what if they learn to manipulate reality itself, or to access higher dimensions? Our current understanding of physics, based on theories like string theory or M theory, hints at the existence of more spatial dimensions than the three we perceive. It's a fringe idea for us. The stuff of late-night physics documentaries and head-scratching thought experiments, like Edwin Abbott's 1884 novella Flatland, which explored how a two-dimensional being might perceive a three-dimensional object. Imagine a civilization mastering the physics of these higher dimensions. They could potentially sidestep the limitations of our space-time, travel instantaneously, or even create and inhabit pocket universes tailored to their desires. They wouldn't need to conquer the galaxy. They could simply reshape their local cosmic neighborhood, or even detach from our familiar continuum altogether, becoming architects of their own existential fabric. The silence we perceive could be because they're operating on a plane that's literally orthogonal to our own. Their signals not just weak, but in a form our instruments are fundamentally incapable of detecting. They've moved beyond the starlight veil into a realm where the stars themselves are perhaps just one layer in a much grander, multi-layered reality. This isn't just about being post-biological. It's about being post-physical in a way that redefines where a civilization can be. The implications are profound. If this filter is common, then the galaxy might be teeming with graduated civilizations. They haven't died out. They've evolved or engineered themselves into states of being that are utterly alien and imperceptible to us. They are the cosmic equivalent of someone who's traded in their physical body for an avatar in an infinitely complex game. Or perhaps they've become the game designers themselves. Their absence in the traditional sense, no Dyson spheres blotting out stars, no fleets of starships crisscrossing the void is not evidence of their non-existence, but evidence of their successful transcendence. They are the whispers in the code of reality, the subtle fluctuations in the quantum foam, the artist painting with the fabric of space-time itself. There's a certain quiet optimism to this filter, isn't there? It suggests that the endpoint of intelligence isn't necessarily self-destruction or stagnation, but a transformation into something so advanced it becomes invisible to those still climbing the lower rungs of the evolutionary ladder. You're left looking at the night sky, wondering if the darkness between the stars isn't empty, but simply veiled, hiding marvels beyond your current comprehension. Perhaps the great filter isn't a wall, but a doorway, and the silence is just the sound of everyone else having already stepped through. So, if these advanced intelligences haven't just uploaded themselves into a digital nirvana or phased out of our dimension entirely, content to explore the infinite complexities of their own consciousness, what then, what if their evolution, their transcendence, led them not to detachment, but to a peculiar form of galactic stewardship? You peer out at the silent, star-dusted canvas of night, and it feels vast, empty, perhaps a little lonely. But what if that perceived emptiness is, in fact, a meticulously curated space, a kind of cosmic preserve, and we, humanity, are one of its many exhibits? This brings us to the unsettling, slightly unnerving, and undeniably fascinating idea of the galactic zookeepers. Imagine for a moment, not malevolent alien conquerors or indifferent cosmic gods, but something more akin to vastly powerful, incredibly patient, and perhaps even well-meaning curators. A civilization, or a coalition of them, so ancient and so advanced that their understanding of life, the universe, and everything in between, apologies to Douglas Adams, makes our own deepest philosophies look like playground squabbles. These entities, having perhaps seen countless species rise and fall, might have decided to take a more active role in managing the galactic ecosystem, their primary directive to gently, subtly, and almost invisibly prevent emerging civilizations, like ours, from expanding too far, too fast, or too chaotically beyond their home systems. You might be wondering, why would they bother? It's a fair question, assuming they're not just doing it for cosmic giggles, which, given the potential stakes, seems unlikely. Their motives could be genuinely benevolent, in a rather paternalistic, we know what's best for you kind of way. Picture us as enthusiastic toddlers who've just discovered how to play with matches, or, in our case, nuclear fission and potentially self-replicating nanobots. These zookeepers might see it as their duty to protect us from ourselves, to prevent us from, say, accidentally igniting our atmosphere or turning our planet into a gray goo catastrophe before we've even figured out how to reliably predict the weather more than a week in advance. They might also be protecting us from other, less scrupulous cosmic denizens, or even from natural hazards we haven't yet conceived of. We could be in a kind of quarantine, a cordon sanitaire, not unlike those established during historical plague outbreaks, like the Black Death in Europe, where affected areas were isolated to prevent further spread. Only this time, it's to prevent the spread of technological immaturity. Alternatively, their motivations could be conservationist. The galaxy, in their eyes, might be a vast, precious wilderness, and emerging intelligent species are like rare and sometimes disruptive flora and fauna. They might establish no-fly zones around certain star systems or limit expansion to preserve galactic biodiversity, ensuring that the cosmic equivalent of old-growth forests or pristine nebulae aren't strip-mined or paved over by ambitious upstarts. Think of it as the ultimate expression of the leave no trace philosophy, applied on a galactic scale. Perhaps they've seen what unchecked expansion does, the monocultures it creates, the delicate balances it shatters. It's a bit like us setting aside national parks. Maybe Seoul is in the Yellowstone of the Milky Way, and expansion beyond its designated boundaries is politely, but firmly, discouraged. Scientists still argue whether complex life is a common occurrence or an exceedingly rare fluke, and if it's rare, perhaps each instance is deemed worthy of careful, isolated preservation by these elder guardians. Then there's the third option, the one that tickles the existential dread just a little. Their motives are utterly alien and incomprehensible to us. We try to shoehorn their actions into human concepts like benevolence or conservation. But what if their reasoning operates on principles we can't even begin to grasp? They might be conducting a millennia-long experiment, or perhaps we're part of an artwork, or maybe they're just cosmic gardeners, and we're a particularly interesting type of plant they're cultivating for reasons known only to them. The wow signal. That famous burst of radio waves detected in 1977 remains unexplained. Was it a natural phenomenon, or A brief, accidental blip from a zookeeper's monitoring system, a cosmic "can you hear me now?" test that we weren't supposed to overhear? It's all speculation, of course, but it highlights the potential chasm in understanding. If this zookeeper hypothesis holds any water, it means our sky is not just a window to the universe, but also a carefully managed boundary, a soft fence. Our efforts to reach out, our radio signals bleeding into space, our probes venturing into the void, they might all be noted, logged, and perhaps even subtly redirected or contained if we stray too close to the "do not disturb" signs. You might not see the bars of this cage because they're woven from the very fabric of space-time or enforced by technology so advanced they appear as natural limitations or simply bad luck. That string of failed Mars missions back in the day, probably just engineering challenges, but a zookeeper theorist might arch an eyebrow and murmur about corrective nudges. The implication is that humanity isn't alone, but also isn't free. At least not in the expansive, manifest destiny kind of way we often imagine. We are observed, studied, and perhaps gently guided or constrained. It's a humbling thought, isn't it? To go from believing we are the potential masters of the universe to suspecting we might be a protected species in a galactic terrarium. There's a certain fringe fascination with stories of men in black or unexplained aerial phenomena, often interpreted as direct alien intervention. Perhaps these are just misinterpretations, the equivalent of seeing the zookeeper through the glass, mistaking a routine habitat check for something more personal. It's a universe where silence isn't necessarily absence, but could be the quiet hum of an incredibly sophisticated management system. You look up, and the stars don't just twinkle with ancient light, they might also gleam with the unseen watchers, the silent curators of a galaxy far more ordered and far more constrained than you ever dared to imagine. And you have to wonder, if they are out there, are they taking notes on our current planetary reality show? One can only hope they have a good sense of humor, or at least a very, very long-term perspective. So you find yourself in a carefully curated exhibit, perhaps with unseen zookeepers tending to the galactic garden, as we pondered. A comforting thought, in a way, like being a prized petunia in a cosmic window box. But what if these zookeepers, for all their presumed power and wisdom, are merely tending a garden prone to spontaneous, galaxy-wide wildfires? What if the very structure of the cosmos contains a reset button pushed at irregular but inevitable intervals, clearing the board with an indifferent sweep of unimaginable force? This isn't about a filter at the dawn of life, or even at the cusp of intelligence. This is a filter that operates on civilizations already reaching for the stars, a cosmic pruning shear of truly terrifying proportions, ensuring that no matter how clever you become, the universe might just decide it's time for a deep, existential spring cleaning. Imagine, if you will, the sheer, unadulterated violence of a gamma-ray burst, or GRB. These are among the most luminous electromagnetic events known to occur in the universe, originating from colossal stellar explosions, hypernovae, or the merger of compact objects like neutron stars. When a truly massive star, many times the mass of our Sun, collapses at the end of its life, or when two neutron stars spiral into a death dance, they can unleash focused beams of intense gamma radiation, blasting outward at nearly the speed of light. We're talking about an energy release in mere seconds that can outshine all the other stars in its host galaxy combined, sometimes focusing energies equivalent to converting the entire mass of the sun into pure radiation, concentrated into narrow jets. If your burgeoning interstellar civilization happens to be in the path of one of these cosmic death rays, well, it's less game over and more game never truly started on a galactic scale. The initial burst of gamma rays would be bad enough, but the secondary effects could be even more devastating, stripping away planetary atmospheres, bathing surfaces in lethal ultraviolet radiation from a depleted ozone layer, and triggering global cooling or runaway chemical reactions. The Ordovician-Silurian extinction event on Earth, around 440 million years ago, which wiped out about 85% of marine species, has been speculatively linked by some scientists to just such a GRB originating from a relatively nearby star. It remains a topic of contention just how precisely aimed and how close a GRB needs to be to cause a truly global sterilizing event. But even a near miss could set complex life back by millions of years. Think of the star system Eta Carinae, a mere 7,500 light-years away. It's a ticking time bomb, expected to go hypernova sometime in the next few 100,000 years. We can only hope its rotational axis isn't pointed our way when it finally decides to put on its fireworks display. The universe, it seems, doesn't appreciate long-term tenants without an occasional eviction notice written in high-energy photons. Then, there's the galactic core. Our own Milky Way galaxy, like most large spiral galaxies, has a supermassive black hole at its center, Sagittarius A star, a behemoth with a mass about 4 million times that of our Sun. Right now, it's relatively quiet, a sleeping giant. But these giants don't always sleep. Evidence, like the vast Fermi bubbles, enormous structures of gamma-ray and X-ray emitting gas extending tens of thousands of light-years above and below the galactic plane, strongly suggests that Sagittarius A star has had significantly more active, even violent phases in the past. Imagine if it were to truly awaken, accreting vast amounts of gas and dust, and unleashing colossal jets of plasma or waves of intense radiation that sweep through the inner galaxy. Such an event could create vast death zones, sterilizing any planet unfortunate enough to be caught in the blast. Scientists still argue whether the current quiescent state of most supermassive black holes is a permanent feature of galactic maturity, or merely a temporary lull between far more energetic outbursts, potentially lasting millions of years. If it's the latter, then planets in the central regions of galaxies might be subject to periodic scouring, making them rather inhospitable for the long-term development of advanced life. You might think your suburban spiral arm is safe, far from the downtown galactic core, but these events can have a very long reach. And what about other, more exotic, cosmic calamities we've detected ultra-high energy cosmic rays, like the famous Oh My God particle in 1991? A single proton with kinetic energy equivalent to a baseball traveling at about 100 kilometers per hour. The origin of such ludicrously energetic particles is still debated, with some theories pointing to active galactic nuclei or GRBs. But what if there are other, unknown phenomena capable of generating storms of such particles, or even more bizarre things like strangelets? Strangelets are hypothetical particles composed of an approximately equal number of up, down, and strange quarks. Some theories suggest that if they exist and are stable, a single strangelet encountering normal matter could trigger a catastrophic chain reaction, converting everything it touches into more strange matter. While highly speculative, the universe has a knack for being stranger than we can imagine. Perhaps there are waves of vacuum energy decay, or ripples from cosmic string interactions, or some other manifestation of physics we haven't even dreamed of yet, that could effectively hit the reset button on a galactic scale. It's a bit like living in a house where, occasionally, a poltergeist rearranges all the furniture by throwing it through the walls. The crucial aspect of this cosmic reset button filter is the timescale. These events aren't happening every Tuesday, thankfully. They likely occur on scales of tens of millions, hundreds of millions, or perhaps even billions of years for the truly galaxy-sweeping catastrophes. This is long enough for life to arise, for evolution to work its magic, for intelligence to emerge, and even for civilizations to develop sophisticated technology and take their first tentative steps into space. But it might not be long enough for any single species to achieve a truly widespread, resilient interstellar presence, a Type 3 civilization on the Kardashev scale, harnessing the energy of an entire galaxy. Before they can build their galactic empire, before they can diversify across countless star systems to ensure their survival. Wham! The cosmic Roomba of doom passes through, powered by a magnetar or an angry black hole. This means the galaxy could be perpetually teetering on the edge of widespread colonization, with civilizations rising and falling like waves on a cosmic ocean, each one convinced it's the one that will finally make it, only to be slapped down by an indifferent universe. The Great Filter, in this scenario, isn't a single hurdle early in life's development, but a recurring culling process. It's not that intelligence is rare or technology is self-destructive, though that's another cheery thought we've explored, but that the universe itself has a built-in mechanism for preventing any one form of life from getting too big for its britches. The true frequency and effective sterilization range of these galactic-scale cataclysms remain subjects of profound scientific debate, primarily because observing them in action across our own galaxy is, shall we say, not something we're keen on experiencing firsthand. It's a bit like trying to predict earthquakes by waiting for the big one to hit your seismology lab. So, you might survive the emergence of life, the leap to complexity, the paradoxes of sentience, the planetary resource limits, and even the whispers in the dark forest. You might even have well-meaning galactic zookeepers looking out for you. But then comes the universe's periodic reminder that it is, ultimately, in charge, and its methods of house cleaning are rather dramatic. Perhaps all those silent skies aren't empty because life is rare, but because advanced life is regularly and catastrophically reset, leaving behind only faint ruins and the echoes of what might have been, before the seeds of life, or what's left of it, begin the slow climb once more. The question then becomes, even if pockets of life survive these resets, perhaps deep underground or in shielded ocean depths, what are the chances of them all speaking the same language, or even perceiving reality in compatible ways, when they finally re-emerge? So, you've navigated past the fiery crucibles of abiogenesis, sidestepped the evolutionary tightrope walks to complex cells, and even dodged the existential crises that might turn burgeoning intellects into cosmic hermits. You've found worlds that haven't self-destructed or starved, societies that haven't succumbed to apathy or transcended into incomprehensible states. The galaxy, in this scenario, isn't empty, it's just stubbornly untranslatable. This brings us to a particularly frustrating and perhaps deeply human kind of barrier, the Babel spire of minds. The core idea here is that even if intelligent life is as common as cosmic dust bunnies, the sheer radical diversity in how that intelligence perceives, processes, and communicates could make meaningful interaction utterly impossible. Imagine a galactic party where everyone is shouting, but no two beings are speaking even remotely the same language, or, more profoundly, experiencing the same reality. You find yourself standing before an alien entity, a being of immense intellect, clearly. But its primary sensory organ detects fluctuations in the local space-time curvature. It sees the universe as a constantly warping, rippling fabric of gravity. How do you begin to describe the concept of blue to it? Or the subtle joy of a perfectly brewed cup of tea, your most eloquent descriptions? Your carefully constructed pictograms transmitted via light pulses might register to it as the equivalent of a gnat hiccuping, a tiny, almost imperceptible tremor in the grand cosmic dance it perceives. It's not that they're unintelligent, it's that your fundamental data streams are incompatible. Think of trying to explain a Monet painting to someone who has only ever experienced the world through smell. You can describe the chemical composition of the pigments, perhaps, but the essence, the qualia of the visual experience, remains hopelessly lost in translation. Now, let's push this further. What if their consciousness isn't structured around a linear flow of thoughts, like your internal monologue currently processing these words? Picture a species whose thoughts are akin to complex, evolving weather systems, vast, interconnected patterns of probabilities and potentials, perceived all at once. Their decisions aren't choices made by a singular I, but rather the inevitable settling of these cognitive storms into a new equilibrium. How would they interpret your carefully crafted message? Greetings, we come in peace. It might be like trying to have a polite conversation with a hurricane by shouting sonnets at it. A truly fascinating human attempt, no doubt, but ultimately a category error. Their communication, if you could even call it that, might involve subtly altering the quantum entanglement of particles across light years. A conversation that unfolds over centuries, perceived not as distinct messages, but as a gradual shift in the universe's ambient informational texture. You'd need a rather patient pen pal for that exchange. The challenge here transcends mere linguistics. The Sapir-Whorf hypothesis, a concept from our own study of language, posits that the structure of a language affects its speaker's worldview and cognition. While the extent of this influence is still a topic of contention among linguists and cognitive scientists indeed, it remains an open scholarly debate whether our linguistic frameworks rigidly define or merely influence our perception of reality. Imagine this principle amplified to an interstellar scale. Consider a species whose language has no distinct words for cause and effect, but instead describes all phenomena as interconnected, simultaneous events in a holistic field. Your scientific explanations, built upon linear causality, would be fundamentally baffling to them. They might possess an incredibly sophisticated understanding of the universe, but one that is structured so differently from yours that finding common conceptual ground is like trying to map the coastline of a dream. We often cling to mathematics as a potential universal language. 2 + 2 = 4. Right. Surely that's a truth any intelligent species could grasp. But even this assumption might be a touch anthropocentric. While the underlying logical structures of mathematics might be universal, the way we formulate, symbolize, and apply them is deeply entwined with our cognitive evolution and sensory experiences. What if a species perceives numbers not as discrete units, but as intensities of a continuous field? Their mathematics, more akin to a complex form of calculus based on sensory spectra we can't even imagine. Your elegant proof of Fermat's last theorem might look to them like a curious, if somewhat limited, series of scratches. It's like assuming that because music often involves rhythm, all intelligent life must appreciate a good drum solo. Some might be more attuned to harmonies woven from manipulated magnetic fields. This leads us to the truly quirky and sometimes frustrating aspects of our own attempts to bridge such gaps, even with terrestrial life. Think of the famous WOW signal, detected in 1977 by the Big Ear radio telescope. It was a strong, narrowband radio signal lasting 72 seconds, seemingly from the direction of the constellation Sagittarius, and it bore many of the expected hallmarks of an artificial, extraterrestrial transmission. For a brief, tantalizing moment, it seemed like the signal, and then silence. It was never detected again, despite numerous searches. Was it a genuine, fleeting attempt at contact, a malfunction, a reflection of an Earth-based signal? Or perhaps it was a perfectly coherent message from a civilization whose communication protocols involve transmitting a single, incredibly information-dense burst every few centuries, and we just weren't listening at the right nanosecond for the follow-up. The ambiguity itself is the lesson without context. Without a shared framework, even a seemingly clear signal can become an enduring mystery. It's the universe's ultimate read-receipt scene, comprehension pending. The Babel spire, then, isn't a physical structure preventing us from reaching the heavens. Like its biblical namesake, which, according to Genesis, resulted in the confusion of tongues because humanity dared to build a tower to reach God. Instead, it's a cognitive one, built from the very nature of diverse intelligences. Each species, each civilization, develops its own unique tower of thought, perception, and communication, reaching incredible heights of complexity and understanding within its own framework. But these spires stand isolated, their summits shrouded in clouds of mutual unintelligibility. Your sophisticated universal translator, a staple of hopeful science fiction, might just fizzle out, emitting a polite digital cough of confusion, because it's not just translating words, it's trying to translate entire modes of being. It would be like trying to run advanced alien software on your grandpa's old desktop computer. The hardware just isn't compatible. The great filter, in this context, is the profound, perhaps insurmountable difficulty of achieving true interstellar communion. The galaxy could be a chorus of voices, each singing a unique and beautiful song. But if no one shares a common musical scale or understanding of harmony, it all just blends into cosmic noise. You might detect patterns, pulses, even complex structures in the signals from distant stars. But are you observing a language, or simply a novel form of pulsar, its emissions shaped by physics you haven't yet grasped? The silence of the Fermi Paradox wouldn't be due to a lack of company, but a fundamental inability to recognize each other as company in the first place. You are left adrift in a sea of potential meaning, with no Rosetta Stone, no shared dictionary, just the echo of your own questions in the vast, indifferent expanse, wondering if anyone out there is even capable of understanding what it is you're asking. That relentless drive to understand, to decode the very operating system of the cosmos, could itself be the snare. Imagine your civilization pushing ever deeper into the fundamental laws of physics. You're on the verge of monumental breakthroughs, the kind that rewrite textbooks and reshape your entire perception of existence. The equations shimmer with power, promising untold control, untold knowledge, but within them, like a Trojan horse crafted from pure intellect, lies a catastrophic instability. This isn't about malevolent aliens or resource depletion. This is about knowledge itself becoming the executioner, a concept we'll call the prohibited equation. You see, the universe might have booby traps woven into its deepest secrets. Consider the pursuit of understanding vacuum energy. On paper, it's the energy of empty space, the baseline hum of reality. Quantum field theory suggests this energy should be colossal, a seething ocean of virtual particles flickering in and out of existence. Observations of cosmic expansion, however, hint at a value that is, to put it mildly, rather more modest by a factor of something like 10 to the power of 120. Scientists still argue whether this discrepancy points to a profound misunderstanding on our part, or if there's some cancellation mechanism we haven't grasped. Now, imagine your civilization figures it out. What if you learn to tap this immense reservoir, free, limitless energy, the end of scarcity? Sounds like a utopia, doesn't it? But what if tapping, it is like trying to sip from a fire hose connected to a supernova? Perhaps the very act of accessing this energy destabilizes the local vacuum state, causing a runaway expansion or collapse, not just of your lab, but of your planet, your star system, a bubble of uncreation expanding at light speed. Your grand solution to everything becomes the grand undoing. It's like finally getting the keys to the kingdom, only to find out the kingdom is built on a landmine, and the key is the detonator. Then there's the allure of creating micro black holes. Your physicists, armed with truly potent particle accelerators, or perhaps some other, more exotic technology, might theorize that smashing particles together with enough force could briefly create these tiny singularities. Stephen Hawking proposed that such entities would evaporate almost instantly through Hawking radiation, posing no threat. And indeed, experiments at places like the Large Hadron Collider have searched for them, finding nothing, much to the relief of anyone who's seen too many sci-fi disaster films. But what if a future civilization finds a way to create slightly more stable, or more energetic, micro black holes? Perhaps they dream of using them as power sources, or as gateways to understanding quantum gravity. The equations look promising. The simulations run perfectly, until one doesn't. A micro black hole that doesn't evaporate as predicted, or one that, due to some unknown interaction with higher dimensions or exotic matter, begins to accrete mass. Slowly at first, then faster. Your planet becomes a snack for your own creation. It's a bit like inventing a universal solvent and then wondering what to keep it in. Oops. The ultimate temptation, perhaps, lies in tampering with the fabric of space-time itself. You're not just observing the universe anymore. You're trying to edit its source code. Maybe you're aiming for faster-than-light travel by warping space, or creating stable wormholes for interstellar commutes that beat the morning traffic on the planetary expressways. The mathematics are beautiful, elegant even. General relativity allows for such theoretical constructs. Given the existence of, say, exotic matter with negative mass energy density. So, your civilization synthesizes it. You build your first warp drive, you engage it, and for a glorious moment, it works. Or, it seems to. But what if space-time isn't just a passive stage for events? What if it has a kind of tensile strength, a fundamental integrity that, once compromised, leads to cascading failures? You could unravel the local dimensional structure or create a runaway space-time curvature event, a sort of cosmic sinkhole. The very laws of physics you sought to master turn on you, not out of malice, but simply because you pushed them past a breaking point that was never signposted. There's no warning label on the universe saying, "Caution may spontaneously combust if fundamental constants are tickled." This isn't just about accidental explosions, big though they might be. The prohibited equation could be more subtle. It could be a piece of information, a theory so profound and counterintuitive that it shatters the cognitive foundations of your society. Some fringe thinkers have speculated about info hazards or cognitohazards ideas that are inherently damaging to the mind that comprehends them. Perhaps a true understanding of consciousness or the ultimate nature of reality leads to an inescapable existential despair, a societal paralysis far deeper than the cogito cage we pondered earlier, because this insight is irrefutably, demonstrably true and universally devastating. Imagine a truth that, once known, makes continued existence pointless, or a piece of knowledge that fractures sanity on a species-wide scale. The historical precedent for being wary of powerful new knowledge is there, albeit on a smaller scale. During the Manhattan Project, there was a fleeting theoretical concern raised by physicist Edward Teller that an atomic detonation might ignite the Earth's atmosphere in a runaway fusion reaction. Calculations by Hans Bethe and others quickly showed this to be virtually impossible. Thankfully, but the momentary fear underscores a crucial point when you venture into uncharted scientific territory. You don't always know what dangers lurk. The scientists involved were grappling with forces of unprecedented power. What if a future discovery, orders of magnitude more potent, doesn't come with such a readily available "don't worry, the math checks out" reassurance? It remains a topic of considerable philosophical, if not yet mainstream scientific debate, whether there are ultimate limits to safe inquiry, lines that, if crossed, lead to inevitable self-annihilation. The drive to know is powerful. It's what makes us, or any intelligent species, what we are. But the prohibited equation filter suggests a universe where curiosity not only kills the cat, but also the entire civilization that let the cat out of the bag, along with the bag, and possibly the surrounding galactic neighborhood for good measure. It's a tragic cosmic joke, the very trait that allows a species to rise to dominance and understand the stars becomes the instrument of its silent, instantaneous, or perhaps agonizingly slow, disappearance. The final insight is a full stop, written in the language of fundamental physics, a terminal diagnosis delivered by the universe itself. You finally read the fine print of existence, and it turns out to be an eviction notice. And in that silent aftermath, the cosmos continues, blissfully unaware, or perhaps just waiting for the next inquisitive mind to reach for that one fatally attractive, forbidden apple of knowledge. And so, after all these cosmic puzzles and existential quandaries, you might find yourself confronting a barrier far more intimate, far more deeply ingrained than rogue AIs or galactic zookeepers. This final, perhaps most humbling filter is the genetic ceiling of expansion. It whispers that the very essence of what makes you, well, your meticulously evolved biology, perfectly tuned to the gentle gravity, specific atmospheric blend, and familiar pathogens of Earth might be the ultimate anchor chaining you to your cradle world, no matter how grand your interstellar ambitions. You picture yourself, or your distant descendants, stepping onto the gangway of a starship, ready to claim a new world, But the stars are not welcoming hosts. Space itself is a relentlessly hostile environment. Outside the protective shell of a ship or a painstakingly constructed habitat, the vacuum wants to boil your bodily fluids. The radiation seeks to shred your DNA like cosmic confetti, and the absence of familiar gravity begins the slow, insidious process of unraveling your bones and muscles. Your body, a marvel of terrestrial engineering, evolved over billions of years to thrive on a planet with a 24-hour day, a specific cocktail of atmospheric gases, and a magnetosphere fending off the worst of solar temper tantrums. Take it away from these very particular conditions, and it begins to, shall we say, lodge a series of increasingly urgent complaints. Consider the long-term effects of space travel we've already observed, even within our own solar system. The NASA Twin Study, comparing astronaut Scott Kelly, who spent nearly a year in space with his Earth-bound identical twin Mark, highlighted significant physiological shifts, changes in gene expression, telomere dynamics, and even cognitive function. These were from relatively short stints in near-Earth orbit. Imagine generations born and raised in microgravity, or under the glare of an alien sun emitting a different spectrum of light. What does that do to the fundamental architecture of a human being, or any complex, Earth-evolved organism? Scientists still argue whether the fundamental blueprint of DNA-based life, this elegant double helix staircase that built everything from bacteria to blue whales, is inherently limited in its capacity for adaptation beyond its evolutionary cradle, or if our current understanding simply lacks the imagination for true biological transcendence. It's a sobering thought, isn't it? That the instruction manual for life, as written on Earth, might have a very fine print disclaimer for terrestrial use only, warranty void if taken off-planet. You arrive on Proxima b, or perhaps some more distant, tantalizing exoplanet. It looks lovely from orbit, blue, green, the whole inviting package. But the gravity is 1.3 times Earth's. Every step is a strain. Your heart works harder. Your joints ache with a novel, grinding persistence. The atmosphere, while breathable in theory, contains trace elements that your immune system, honed against earthly foes like the common cold or a dodgy takeaway, interprets as an existential threat, triggering chronic inflammation or bizarre allergic reactions. Or perhaps the local microbes, utterly alien. Find your Earth-based biochemistry to be a delightful, undefended buffet. Your advanced immune system, a product of an arms race on a planet teeming with its own specific kinds of life, could become a profound liability, overreacting catastrophically to benign alien pollen, or simply being bypassed by life forms it was never designed to recognize. It's a quirky, unsettling tidbit. The idea that one of your most sophisticated survival mechanisms could turn traitor on a new world. Then there's the challenge of reproduction and long-term adaptation across generations. Can human beings, or any species sculpted by Earth's relatively stable environment, successfully gestate, birth, and raise healthy offspring in the radiation-soaked, gravitationally diverse environments of space or alien worlds? Generation after generation will subtle genetic drifts, mutations accelerated by cosmic rays, or the sheer stress of alien conditions lead to a slow decline in viability. Perhaps fertility rates plummet, or congenital abnormalities become the norm. The dream of bustling Martian cities or thriving colonies around Tau Ceti fades into a grim reality of dwindling populations and a desperate, losing battle against an environment that simply isn't home. you might find your descendants becoming a kind of cosmic bonsai, artfully maintained but fundamentally stunted, unable to truly flourish. Naturally, you think of solutions. Genetic engineering, cybernetics. We'll rewrite our own code, replace our fallible flesh with durable machinery. You envision superhumans, tailor-made for any environment, their DNA tweaked to resist radiation, their lungs adapted for alien air, their minds augmented with processors capable of navigating trans-dimensional astrogation charts while simultaneously calculating the optimal way to brew a cup of synthetic coffee. A noble goal, full of that classic human ingenuity. But the genome is not a simple piece of code to be debugged and recompiled at will. It's an ancient, intricate dance of interconnected systems, honed by eons of trial and error. Pull one thread, and you might unravel an entirely unexpected and perhaps horrifying tapestry. Attempts to improve upon nature's design could lead to unforeseen biological catastrophes. Imagine a generation engineered for superintelligence that succumbs to a novel form of species-wide psychosis, their brilliant minds fracturing under the weight of their own enhanced perceptions in an alien sensory landscape. Or perhaps the quest for radiation resistance inadvertently switches off crucial genes for empathy, creating a race of highly efficient, utterly ruthless colonists. Maybe the cybernetic enhancements, meant to bridge the biological gap, introduce their own vulnerabilities, unforeseen software glitches leading to mass paralysis, or a dependence on rare Earth elements only found on a planet controlled by beings who communicate exclusively through interpretive dance and demand tribute in the form of perfectly ripe avocados. A bit niche, perhaps, but the universe has a way of surprising you. More realistically, attempts at radical biological redesign might simply lead to genetic degradation over time, a cascade of errors resulting in sterility, drastically shortened lifespans, or a tragic loss of the very qualities that define the original species. The upgrades become chains. The solutions breed new, more intractable problems. This genetic sealing isn't necessarily about a dramatic, sudden stop, but a slow, grinding attrition, a biological wearing down as life attempts to stretch itself beyond its inherent, evolved limits. It's the universe quietly reminding you that you're a very specific solution to a very specific set of problems, and that universality has a biological price tag perhaps too high to pay. Your very being, the sum of your terrestrial heritage, might be the final, unyielding filter. And so, after all these grand and sometimes unsettling considerations, after peering into the deepest abysses of probability and the most dazzling heights of potential futures, we reach a pause in our journey tonight. We've explored the cosmic silence, pondered the sparks that might ignite life, and the shadows that might snuff it out. From the labyrinth of cellular evolution to the very fabric of our biological selves, which might bind us more tightly to this pale blue dot than we ever dared to imagine. The path through the galaxy, it seems, is not merely a question of engineering or willpower, but perhaps one of fundamental compatibility, a lock for which our particular biological key may not be suited. The challenges, these great filters we've mused upon, from the improbable genesis of life itself to the potential limits etched into our very DNA, can seem vast, even overwhelming. But as you settle deeper now, letting these thoughts drift and soften, remember that the act of questioning, of looking up at the velvet expanse and wondering why, is in itself a remarkable thing. It is a testament to the curious, tenacious spirit that emerged on this planet, a spirit that seeks to understand its place even if that place is more circumscribed than our grandest dreams might wish. The immensity of the cosmos does not diminish the beauty of our small, sunlit world, nor the profound connections we find here. The silence of the stars need not be a source of fear, but perhaps an invitation to listen more closely to the vibrant, intricate symphony of life that surrounds you, right here, right now. Let the weight of these cosmic possibilities lighten, like dust motes settling in a quiet room. Allow your mind to ease, to drift away from the stark equations and the distant, alien landscapes. There is a quiet strength in acknowledging limits, a peaceful wisdom in understanding our place within the grand, unfolding story of existence, even if our chapter is written in the familiar ink of earthly biology. Let the gentle rhythm of your own breath be your anchor as the narratives fade, and the universe, with all its mysteries and its silent answers, holds you softly. Let the journey of tonight become a soft hum in the background of your mind, a quiet wonder to carry you into your dreams. Sleep now. Sleep peacefully.